To begin today's lesson, we have our warm-up, and the first one tells us to write 6.25% as a decimal and fraction. And note that currently it is a percentage, it is not a decimal. But to make it into a decimal, remember we have to take 6.25, our percentage, and we move our decimal spot 2 places to the left, because that's like dividing by 100. And so we end up with 0.0625. And this is what you would use in a percent equation. As a fraction, this is what we would use in a percent proportion. We take our percentage, 6.25, and we just put it over 100. Our second problem, we need to solve for x. What I like to do, we draw our line down the middle, combine like terms on both sides. So we can combine 5 minus 7, negative 2 plus 4x equals, and on the other side, we need to distribute first. 4x plus 12 minus 2x. Then here, combine like terms. Negative 2 plus 4x equals 2x plus 12. Now, I'm going to move my 2x over to the other side, so I'll subtract. Negative 2x plus 2x equals 12. I'm going to add the 2 to both sides, so 2x equals 14, and divide by 2 to get x equals 7. Today's I can statement is I can express change as a percent when working with markups. And markups are so similar to markdowns, except now, rather than subtracting the markdown, markup, we're going to add. In order for us to find a new markup price, we first have to find the markup amount. And once again, using our percent equation, which is why we've been practicing it. We have our percent times our whole is our markup. Finding that is our first step. Our next step is then putting it into our equation, which is step number 2. We take our cost, the whole, the initial price, our starting amount, plus, rather than minus, this markup from up above, and that equals our new price, or what's the increased price. And remember, when using percent values in our equations, up in this percent equation right here, our percent has to be in decimal form. We cannot leave it as a percent. Our first problem says that I work on a produce farm. Last summer, I sold sweet corn for $5 a dozen. This summer, the price of sweet corn increased by 10%. How much does sweet corn cost now for 1 dozen? Just like yesterday, we start with the change. So we're going to find our markup today. And our markup is our percent equation. So we take our percentage in decimal form, so 0.10, times the initial cost of $5. And we end up with 50 cents. We now have to take our markup and put it into our equation. So we take the cost, or the initial, of $5, plus, because it's going up, our 50-cent markup. And that will equal our new price of $5.50 per dozen. And that's it. Our next markup problem says that my hometown of Allenville had a population of 28 people when I was in middle school. Now my town's population is about 22% larger. About how many people live in Allenville? And so once again, a markup problem. Start with our markup. Markup, the percentage increase as a decimal. 0.22 times initial amount of 28 people. And that gives us 6.16. So that's our markup amount. Now we take that and we put it into the equation. So we will take our initial cost or amount of 28 plus, because it's going up, of 6.16, and we end up with 34.16 as the new amount. However, because it's asking about how many people, we're going to round, because you can't have 16/100ths of a person. So I am going to round down to 34 people. And that is my answer. Our next story problem says that last month a painting that I wanted to buy was $15. Now the picture costs $38. What was the percent increase in price for the picture? Notice we're no longer finding the new cost or amount. We are finding percent increase. So let's take it slow. Start with our markup. Markup, remember, we take our percent. It's our unknown, and so we'll call it X, times the initial. It was 15, that's what it started as. The only way to simplify is to write it prettier. 15x. We then take that markup and put it into our equation. So we take our initial, was 15, plus, because it's going up, our markup of 15x equals the new cost of $38. Our next step is solve for x. So we subtract 15. 15x equals 23. Divide by 15. And x equals 1.53. However, remember, when it's in our percent equation, that's a decimal. So this is a decimal. And we need to change it to a percent. Remember, in order to change a decimal to percent, we multiply by 100. And we end up with 153% increase in price. It's okay that it's over 100. And it was even 153%. Our next problem says that I bought a new computer for $540. However, I learned that this was 15% more expensive than what it cost last month. What was the initial price of the computer before the price markup? So we're finding the old cost. $540 is our new cost. 15 is our percent, and we needed to know the original price. So, like always, let's start with our markup. Markup, you take your percent in decimal form, 0.15 times the initial cost, which is our unknown, and so we are going to call it x. So we have 0.15x for the markup. Now, putting it into the equation, initial price, unknown, we're going to call it x, plus our markup, 0.15x, equals our new cost of $540. And remember, in front of this 1 right here, in front of the x, we have a 1. So, like terms, let's combine. 1x plus 0.15x is 1.15x equals 540. Divide by 1.15, and we end up with x equals $469.57. Read the problems carefully and set up the process slowly, just like we always do. Our last problem today says that last Friday I bought gas for $2.05 a gallon at Quick Trip. Today when I put gas in my car, it was 4% more expensive per gallon. What was today's new gas price? So, start with our markup. Markup. Percentage increase, 0.04 as a decimal, times the initial price of $2.05 gives us 0.082. Now, take our markup, put it in the equation. Initial cost, 2.05, plus our markup, 0.082, and that equals 2.13 when rounded to money. However, don't forget your label. So gas was $2.13 per gallon when I got gas today.